So here we're told that when k to the 4 is divided by 32, the remainder is 0, which in other words means that k to the 4 is a multiple of 32, 32 times some integer. So the question is, what can we deduce about k? Because that's what the question is. So we know 32 will do a prime factorization, it's 2 to the 5. So you'll notice that k is an integer. So for k to be an integer, the power of 2 here has to be, the exponent of 2, I should say, has to be divisible by 4. Otherwise, k won't be an integer. So that means that from q, I at the very least, I need 2 to the power of 3 and then some other integer. And the reason for that is because I have the k would be the fourth power of all these, and that would give me a form for k, which is 2 squared times, let's call n, another integer. So this logic, I mean, you'll see this in other questions too, where they make different types of statements, but because k is an integer, that forces on whatever this other piece is to have at the very least 3 2's, because if, let's say this was a single 2, 2 to the 6, can't just be the prime factorization in k to the power 4, because then k will not be will not have a 2 as a prime factor. So that's why we need a 2 cube here at the very least. It could be more, meaning 2 cubed times 2 to the 6 to anything, but at the very least we need 3 2's. So what this really boils down to is that k is a multiple of 4. That's really the conclusion. Question is, what's the remainder when k is divided by 32? So possible values for k are 4, 8, 12. And you'll see if k is 4, we can have a remainder of 4. So 2 works. 12, 16. So here the remainder would be 8, 12, 16, 20, 24, 28, 32. Here the remainder would be 0. And then if you go to 36, the remainder would be 4. 40, it would be 8. It will just cycle in this. So these are the only possible remainders, meaning 0, 4, 8, so on and so forth, up to 28. These are the only possible remainders for k when divided by 32, which means neither 2 nor 6 are possible. The answer is 4, and that is 2 only, choice C.